I'm Divya, and this is nutramap, the nutrition tracker of my dreams. nutramap has the perfect balance of convenience, flexibility, and accuracy. It uses natural language processing, so you can type in what you had to eat yesterday as though you're texting your mom about it, and nutramap breaks down the meal into ingredients, estimates the amounts of each, and maps each ingredient to the most comprehensive nutrition database there is, which is the USDA's. So in that database, there are thousands upon thousands of food, like every version of every raw ingredient you can imagine, and many, many, many branded foods as well, and a full nutrition panel for each one for like 70 different nutrients. For example, if I typed in yogurt, it could be any of these and more. So, parsing user input and mapping it as accurately as possible to an entry was no minor task, especially because I wanted to keep the app as fluid and responsive as possible. So, to do this, I combined dense and sparse indexing for each ingredient. I used Facebook's Face for vector similarity search and TypeSense for keyword based search. So every single ingredient got put through each index, and the generated similarity scores were combined using a reciprocal rank fusion algorithm. This is similar to how most RAG pipelines work. It takes into account both absolute similarity score and relative ranking, and most importantly, it accounts for ties. The reason this was important was because TypeSense returns equally ranked values in a kind of random order. So before I adjusted the algorithm to take ties into account, I had this issue where very simple ingredients got comically incorrect results because so many entries got a perfect match. For example, I would type in butter, and the first result would be pound cake made with butter instead of the ingredient itself. Another way I kept calculation times low was by using multi-threading wherever possible. Pretty much every loop and non-dependent set of statements on my backend is executed in parallel using Python's async library. Another really big problem was the fact that Face is very slow and can get super expensive as well. And I minimized both time and cost by saving the embeddings for each food in my Mongo database and then caching the generated Face index into a bin file. And then also saving that index into Fast API's app states to keep retrieval times as low as possible. I didn't have to do this with the sparse index because that's a feature that's already built into TypeSense. So originally I used Mongo's built-in queries and a Python library called RapidFuzz for sparse indexing, but it ended up being kind of slow and it also didn't have BM25 built in, so TypeSense ended up being a very good switch. It is actually built with Python using Fast API, and the front end uses React with Recoil for atomic state management. And both are Dockerized separately and deployed, backend on Google Cloud and front end on Vercel. It was very important to me that the UI was simple and smooth and responsive, which was a really big challenge with the functionalities I wanted to implement. I was able to structure my components and take advantage of Recoil's granular re-render to keep my interface very smooth, even though there are a lot of calculations and API calls that happen every single time the user does anything, from deleting a food to adding one. As you can see, the nutritional averages, both for the current day and for the current time period, are recalculated every time. But all of these operations are encapsulated away in hooks, so the rendering logic is kept nice and separate from all the data fetching. And I also used memoization of values, virtual scrolling, debouncing when typing, and all the other little tricks that keep things smooth. All of those have been implemented. And of course, you can never forget the power of a nice animated transition to keep the user from getting bored. For example, the first step of the processing pipeline is to break down what the user types into individual meals. So you know the number of new ingredients well before you know exactly which database entry they're mapped to. So I was able to make them blur into existence so the user knows that something is happening well before they actually fully materialize. And that way the actual indexing is also moved into the background as a background task so you can still use the app while it's happening. So the UI is very simple. You can edit the food, the amount, and the date of each log just by typing on them. And you can also click on the date divider to see the average intake for any day and use a calendar picker to adjust what time period this average value in this column is being calculated over. The arrow keys let you cycle through time periods as well, and it adjusts the length of the current period. So you can compare yearly, monthly, weekly, even half-weekly averages very easily. There's a super simple account page where you can change your name and email, delete your account, log out. Authentication is handled using JWT tokens, and eventually you'll be able to add custom foods and recipes right here. I love nutramap because you can be as specific and careful as you have the bandwidth to be. Some days I'm feeling extra enthusiastic and I measure out everything I'm eating on a kitchen scale. Other days, it's all I can do to jot down a quick note and go. Mass is actually the most accurate way to measure nutritional components. Other apps use volume or rough estimations or barcode scanning, all of which is fine, but it's not that accurate. And the calculations they're actually doing are sort of a black box. Here you can see the exact estimations. You can see how those they're being derived. You can double check them using a kitchen scale and adjust them if you want. And you can track over 70 nutrients, some of which I've never even heard of. And you know that all the data is backed by research.